Thank you everyone for joining today's webinar. Mammoth-AI will be presenting on how to adopt machine learning and AI in continuous test. We'll just wait a couple of minutes for everyone to join in and then we'll kick it off. All right, I think we have a decent amount of people who've joined in already. We can go ahead and start off the conversation, and then as people join in, we'll go ahead and continue forward. Today, we'll be learning from industry leaders in technology and testing from Azan Taseer, who is the CTO of Mammoth-AI, and Eric Finver, the founder and managing principal of Mammoth-AI. They'll be talking and walking us through the best practices on how to adopt machine learning and AI in continuous test. Having said that, I'll hand it over to Eric to start off the conversation in today's webinar for us.
Thanks, Fad. And hello, everybody. Good afternoon, good evening, good morning, depending on where you are. It's nice to have you with us. And we're going to talk a lot about how to use ML and AI in continuous testing and how to infuse that into your testing efforts. So it's a powerful presentation and discussion. And I hope you'll take the opportunity to stay with us for the entire duration and also ask questions at the moment. We'll have the chat link open for Q&A at the end. So we started our organization in 2019. We focused primarily on the testing space, although we do a number of different things today from a service standpoint, software development, testing, and production support. But we do focus heavily in the testing space, and I hope based on our presentation, you're going to get a sense of the significant capabilities in this domain and this rigor in this area of control that we're going to present. So because of our abilities in the testing space, we really were able to brand ourselves and create the first of its kind in terms of using ML and AI in the testing area. We've branded it as QA as a service. It is a service as a service, and so it's branded as that, and it goes by QAAS at the bottom there. You see it on the screen. So let's go to the next slide and take a look at some of the highlights. Just a couple of bullets on us to give everybody a sense of our organization, some qualifications, etc. We've accomplished more than 100 projects that we've delivered, 500,000 hours of testing under our belt over the years. We call it a team of super testers. There are about 180 folks in the organization, and super testers because we have the ability to leverage ML and AI in our testing efforts. 400,000 scripts have been executed in really 3 years. 3 years of executing this and using ML and AI in the area of testing, which has resulted in zero defect leakage across our clients. It's very, very powerful qualification. We have a global presence, diverse domains that we support, so we're pretty familiar with the different types of problems that can occur in different industry sectors. Team has there's a team of engineers that focus primarily on QA. So and of course we pride ourselves in delivering high quality and cost effective services in this space. Let's move to the next slide. So today's webinar is all about how we leverage ML and AI in the testing space and adopting it into a continuous test discipline. And we're going to talk about how that gets done. And really, we'll set the stage. Most of you will know exactly where we are from an industry standpoint and why we are at the place we're at. I'm going to just highlight them just to reiterate and set the baseline. And then my colleague, Azan Taseer, will take over and he'll talk a little bit about, how to use ML and AI. What are the benefits of using that? How does it tackle and address the problems that we have today? And then obviously we'll entertain questions. So let's move on to the next slide. Just highlighting the recent failures. Most of you probably already know this. These are in the news. They are very clear and present. And these are large organizations. So when these types of things happen, it's all across the press in every format. And of course, the impact is huge. It's huge to the organization. It's huge to the people that are running these departments because these are career impact issues. And then, of course, for the teams that are working in these organizations, it's a huge impact because when you have a failure like these, they don't go unnoticed and they don't go unpunished. So just we highlighted a few of them. There are many, many others. It's almost like every week or two we're seeing some organization that's had some form of failure uh, in their in their production system that becomes extremely painful. The NHAS is a government organization in the UK. They had a scheduling glitch. It affected 10,000 appointments. They duplicated and overbooked appointments, etc. Uh, this, besides having egg on your face, just causes a lot of heartburn for the internal organizations that are trying to follow their processes and of course the business and the administrative people within the organization obviously impacted negatively by this type of error. Equifax, a global credit scoring entity, had incorrect scoring going out to everyone or their clients across the US. They are one of two or three large credit scoring agencies that most of the financial sector in the United States comes to rely on or does rely on. And if you live in the United States, then you'll know all about it because it's part of our credit scoring system. And of course, that was a huge impact, and that happened very recently. The New York Stock Exchange, also globally known, um, transacting billions of dollars in stock transactions and other types of instruments every day, and they had a price, an abnormal price defect that halted trading for them. And you can imagine the impact to the traders themselves and the people that are investing. Every second of lost opportunity in a stock transaction um, has a negative impact to you in terms of being able to sell or to buy. So very significant impact there. And then, of course, what happened last week with CrowdStrike bringing down large swaths of infrastructure across the globe, the airlines, the banking systems, and other types of businesses, supply chain, et cetera, not just affecting process and dollars, but also affecting, people's lives, their personal lives in many ways. So these are all prescient. They're also, they're clear and present, and but it tells us something. It tells us that we're failing. We're failing as an industry discipline. So let's go on to the next slide and talk a little bit about that and why it's happening. So testing is coming up short. It's clear it's happening. We're seeing this kind of stuff in the news every day. There are a number of reasons and some things that we should highlight. First and foremost, the complexity of the modern tech stack today. Not only are you responsible for your own applications that you're creating, but you're reliant on so many others. Because of the design of modern delivery in software, our cycle times are more and more reduced. When I started in the business, you had a good 3 to 6 months to actually do something, and today, you have 2 to 4 weeks and maybe less when you're doing enhancements or new feature releases, etc. You have less than that, maybe sometimes a week or less. So that's causing a major heartburn for delivery organizations and dev shops. And then the whole process or the whole, let's say, um, uh, business adoption of digital transformation and doing things much faster and exposing those things that we do to a broader audience, a much broader audience. So if you think about all of the technology that you use today, just all of us, things are now being pushed out into self-service. We're doing self-service for all types of different things in our lives in terms of how we use technology. And so because of that and that push to move, things that we do into a transformative state of enablement, this has caused a high degree of complexity that affects bullet one, and then of course it makes all of our potential errors and things that we've overlooked so much more glaring. Okay, so the question arises, did we test enough? Obviously we didn't, right? But that's a loaded question. Did we test enough? Because the first question, did we test enough? The first question that's going to come to mind is did we test the right things? Because given the fact that we have limited time and limited capital and limited resource to get testing done, we need to make sure that we focus on the right things. And so these questions become very critical in terms of us understanding what is the right approach to tackling the current state of affairs, which is we're coming up short. Okay. And I submit to the audience that and my colleagues across this, the horizontal area of testing discipline is, are we accounting for the known knowns, which is, did we test the right things? But also, are we accounting for things that we didn't get to, right? The known unknowns, the things we didn't get to because we forgot, the things that we didn't get to because we didn't have time. Okay, so those are the known unknowns. And then what about the unknown unknowns? The things that actually exist in the application that a user is going to execute, but we didn't account for to test because we didn't think the user would do that. Or it's an edge case that we just didn't consider, but it exists in the application. Okay, so let's move on to the next slide and see if we can tackle some of these kinds of things. Now, all the things that I've mentioned in the previous slides, I mean, these are not new to anybody that's involved in testing and understands the current state of affairs of testing in the modern development cycle. But when we address these problems, we address them in kind of a standard way, right? We're going to add more people to see if we can cover more of it. We're going to try to add automation and shift left principles as best as we can. And the automation that we're going to add is, in many cases, 2 steps forward and 1 step back because of the maintenance that comes with the automation that's available in market. And then, of course, when all else fails and we can't hire people and we don't have enough resources, but the time is still the time, we're going to force our developers to test, right? And that's never good. That's not best practices for all of us on the call. And we know that it's not a good plan of attack, because what winds up happening is developers will test their happy paths and they will leave holes in those test execution efforts that you can essentially drive a truck through. So what are the results? The results are we can't scale. We don't have ability to adapt to the shorter cycle times, et cetera, and the complexity of the code. We have a high cost of time and just high cost in general, because we have to get to more. We have to use more manual testing to try and cover all the things that we know can potentially be gotchas out there. So we're worried about that. We're doing a lot less sleeping. And the more manual testing we do, the more friction we're going to cause in the process. So and then we're going to have all the things that manual testing comes with, which is limiting coverage and the adoption or the introduction of human error. So the more manual testing we do, the more potential for human error. and just the more overhead in general. Mentioned a little bit about maintenance of scripts. We talked about using automation and the shortcomings sometimes of that. Of course, we're going to need automation. There's no question, but what is the level of maintenance to that automation and what is the impact there? And then, of course, all of these things are just causing potential delivery delays, tremendous backlog grooming and stuff like that. And so we're continually trying to catch up with tools and a model that doesn't allow for it, right? So how do we address this thing? And that's what we're going to talk about. All right, let's move on to the next slide. So this is the last slide for me, and then I'm going to turn it over to my colleague. The answer to adopting ML and AI in continuous testing is really the answer to the problems we're seeing. And what we're going to do is, while we try to have a continuous test model and continuous test process in our dev cycle, the way to make sure that we get it and we engage and do it in a robust way is to be able to lean on the power of machine to enable this type of testing so that we are testing effectively and we're scaling the test effort. We're doing a lot more with less. And at the end of the day, we're going and moving from something called test coverage, which we follow today as a benchmark, into more application coverage, a much broader interrogation of the application and defining and identifying and addressing quality problems that we weren't able to address before. So I'm going to turn it over to Azan. I've taken up enough time. Azan, over to you.
Thank you very much, Eric. Hello, everyone. Okay, so while Eric has laid out the foundation to support our argument or the topic under discussion, that is the need of ML and AI in continuous testing process. So it is important for us to first understand why do we have to do it? What are the goals that we want to achieve? All right. And Fahd, please, next slide. All right. So the goals behind achieving or integrating or using ML and AI in continuous testing uh, are actually, they're deemed before we invest in this process. So at this point of time when we have to deliver the products to the market as quick as we can, that means we have to release our products very, 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 very quickly. And at the same time, we have to develop in the sprint cycle time. And at the same time, not only that, we have to deliver quickly, the quality should not be compromised. And how do we make sure that quality is not compromised is we find enough defects so that they're not reported in the production environment. So in the testing world or in the testing space, uh, before any decision is made on bringing a paradigm shift in the processes, some objectives are identified. So the most common objectives or the goals associated with the implementation or usage of ML and AI in testing world are what you see on the screen. So, for example, companies would think or organizations would want that ML and AI should help them release their products faster. So, I mean, like reduce the time required for their release cycles. And at the same time, quality is something that I am working on. So, how do I improve? How do ML and AI help me improve the quality and reliability of my products? And is there an automatic way of detecting the defects? Is there a way I can or my tool or my platform can generate test scripts for me? Is there a way that the time that is required to manage my test executions and test scripts can that be altered or can that be made efficient? And at the end, when I do all of these things, at the end, I have to do a lot of effort to maintain all of these things that I have developed. So, is there anything that ML and AI can do to reduce my maintenance efforts? So these are some common goals, and they can be more objectives and goals associated with our investment on ML and AI but these ones are the common ones. All right. So in the light of these goals, we realize there are the capabilities of ML and AI currently being practiced by the implementation of some modern software testing platforms. All right. So the most important, I'll say, the most prominent capabilities that organizations can leverage from are what you see on the screen. So for me, I'll say the most interesting thing is uh, the capability of generating the test scripts automatically. And after that, if AI has generated the scripts for me, AI should be able to execute them. AI engine should actually report defects for me. My scripts are very brittle. I want AI to help fix the problems in my scripts. So that feature is actually self-healing. I have thousands of test scripts and I cannot manage so many execution cycles. So there has to be a way I can manage the scenarios and executions very smartly. So that feature is actually called as smart execution. My application is kind of a dynamic application that has got a lot of images also that support the data. I want to have something that I can use to test my images or the images of my application. So is there a way? Yes. That feature is called visual AI. So these capabilities of ML AI are in the discussion as of now with reference to using ML and AI in testing. So I'll quickly go through the quick understanding of all these features. What do they do? And then we'll proceed to the next steps. Okay. So we call them the concepts of ML and AI in testing. So as the name suggests, AI script generation. So using Gen AI, scripts are generated automatically without manual efforts. Uh, I'll say that yes, ChatGPT is helping us to think of anything is possible in today's world. So this is actually a paradigm shift in accepting the technology. So now, because of all these talks about AI, now people can actually believe yes, anything is possible in this world. I mean, like yes, we can talk about it. But in our world, generative AI can now create test scripts without humans automatically. Many of you who are in this session may not have seen with their own eyes, but yes, this is reality. AI can generate test scripts on its own without humans. And not only that, AI is capable enough to execute the test scripts without human intervention. So let's say you have a test automation platform that has the capability to execute that has an AI engine first, and then that AI engine should be able to execute the test scripts. The sole purpose of doing all these things is to measure the quality of my application or take the control of my quality of the my application. So for that, defect reporting is the most important thing. So for reporting defects, I'll say again, can AI do this? Yes, there are platforms that have the capability of reporting defects automatically. And then when you talk about test automation in traditional ways, maintenance and fixation of or update of test scripts is something that every automation engineer will always talk about. So self-healing feature in AI-based automation platforms is something that can actually take away this pain. So with automatic detection and fixation of broken scripts, we can save a lot of time and actually achieve flawless execution. Similarly, AI is intelligent enough, it can make decisions. It knows what is important for me that I should test and what is not. So selection and prioritization of uh, critical test cases or test scripts is what AI can do for us automatically. Visual AI, as I described earlier, it automatically, like this feature in the platform automatically collects the images, and then we can use these images as our valid accessors. So I think so. I think in my point of view, and I'm sure you'll all agree, these things are new concepts. Most of you, I believe, like you may have some concepts of testing if you're a tester, and if you're a software engineer, you may have studied about the concepts of software testing. But these things are new. These are new topics that we can talk about, and these concepts are or will be the future of testing in very in upcoming time. Next slide, please. Okay, so So it's a little technical stuff that we are going to talk about. Uh, so ML and AI is not something that we can think of like everything is happening on its own. So from the outside, it looks like it's magic, but there is a hardcore science behind it. And that science, in simple words, is a science of algorithms. It's the science of uh, data structures. It's the science of modeling. It's the science of learning, right? So for your learning purpose, we have added some samples that you can see on the screen. These samples are basically the algorithms that are used by the automation platforms to perform these three functions. So for example, for AI script generation, algorithms like supervised learning, natural language processing are used. So these algorithms help generate test scripts faster and automatically or autonomously. And then for healing the scripts automatically, algorithms like reinforcement learning is actually used in the platforms. For executing the platform or automation platforms in a kind of infinite way, algorithms like unsupervised learning, fuzzy logic, supervised learning, and there are many other algorithms that helps the automation platforms to run on it on their own and make decisions, so that ultimately ML and AI features can help us increase our test coverage. I hope so that this makes sense. So if you have any questions related to these, you can please drop in. You can put into the chat later on. To the next slide, please. Okay, so now when we have developed some understanding of how ML and AI, in simple words, is helping us in our testing world, it's like we can just talk about some benefits of it. Uh, you know, Many of you have gone through the ISTQB syllabus, and the first certification that you would do is a certified foundation level tester, CTFL, and there are principles of testing written in it. I hope this is that section in which we say that, uh, or maybe somewhere near to it in chapter one, it says that extensive testing, exhaustive testing is not possible, right? So yes, everyone used to believe this until ML and AI came into this in this usage. So we used to say that 100% testing is not possible. It's impossible to test every application up to 100%, right? And we all used to just talk about it every day. But I think so the concepts will be revised now, right? So with the help of ML and AI, it is kind of possible to achieve nearly 100% application coverage. And how does it happen actually? So you know we create manual test cases. We developed we develop deterministic test scripts for against those test cases. That's a traditional way of doing the automation. But when we say that AI is going to automatically or autonomously do our execution or create test scripts for us, then we talk about two other scenarios. The scenario number one is the known unknowns. We know that there are some components of our application, maybe on UI, under the UI, on in the APIs in the database. We know they are there there are some components that we cannot test. Maybe we don't have the capability, right tools, right people that can test those components, right? And we know about it. So ML and AI features can actually cover those known areas that uh, we haven't tested, right? Or we cannot test. And similarly, what about the components of the application that we never know that they exist? We never thought about them. So from white box testing aspects, most of the other than Apple, Google, Microsoft, maybe white box testing is not really often done by the testers or hardcore QA engineers. So, or maybe it's done up till unit testing by the developers, but still there's a lot more to do in white box testing. And in light of that, there are some components of the applications that we do not know they exist, right? So those areas, those components can be uncovered by ML and AI. All right. So they can be the edge test cases. They can be those broken parts of the application like broken links, like broken APIs, or anything. I'm just giving the example that we can never even dream they exist, but we can test them. ML and AI will create test scripts for us on top of those unknown unknowns. All right. The second most important benefit is the early detection of the defects. So ultimately, we all have studied SDLC and STLC in detail. The sooner you detect the defects, the better it is for us, and ultimately it saves our cost. So the formula is simple. ML and AI will detect defects for us earlier. That is equal to, the friction in the process will be reduced, and ultimately the cost will be reduced. And in simple words, this approach is actually called as shift left approach, right? So ML and AI helps us in enabling the shift left approach. Next slide, please. Further, there the benefits of ML and AI are, we talked about it, the presence of the visual capturing of the visuals of the application. We cannot believe everything the tool says. So in today's world, there are the tools that automatically perform testing for us. They capture everything in form of the visuals, so that we just don't have to believe because we trust in AI, but we really can get to see something in form of a material to believe actually. So seeing is believing. And then uh, you know uh, by the help of this particular feature and by the help of good logs, ML and AI features are actually reducing the time to verify the legitimate defects. Now, because you don't have to spend time debugging thousands of lines of code, it's just that you have a perfectly reported defect. All that you have to do is to see the defect and see what AI has reported for you. So, and if it has generated a test script, if you still don't want to believe that, you can export the test script and run it as an individual test script. So that's how you can quickly perform the process that is called as steps to reproduce. All right. And with the help of ML and AI, there are platforms that are allow that are ha- that that allow us to do unified testing. So this approach is basically about the facility of performing multiple types of testing with multiple approaches of testing in just one platform, in just one unit. So, I mean, like, just imagine having a facility of doing your functional, non-functional, like load, regression, shock, and stress testing, along with your routine regression testing and exploratory testing and your smoke testing. Add your scripts to the pipeline. So it looks amazing. So I think so. We should, if we get a chance to see this kind of a platform, will become the fans of ML and AI. Actually, next slide, please. Okay, so here's a sample of one of the platforms that we got to use recently, and this particular map is actually called as coverage map. So it looks like a map actually. So we call it coverage map. So uh, obviously it'll not make sense until you get to see it in real, but I'll just try to explain it. So uh, you know there are parts of the application in terms of the branches and the statements. So, I mean, if again for the testers who have done the CTFL certification or any advanced certification, you may have solved the algorithms or numericals related to the branch coverage, path coverage, statement coverage. All right. So when you solve those numericals, actually, what you're trying to do is that you are creating a pseudo of your application code. So in visual, your code looks like this. So there is a path, and that path is actually your flow from login. Let's say you can take example of Facebook. That's the common application. So what is your path actually? You begin from login, and when you land into the home page, the first thing you can do is you can click on your liked pages. So that's path number one. Path number two could be from login. Instead of going to pages page, you can open your friends page. That's path number two. And from your friends page, you can go to your videos page. So all of these interactions, all of these, flows that you would create or you would perform So these are basically the paths. All right. And at the end, if you talk in sense of the code, so this could be drawn like a map from, that gives you a high level view of how, okay, I started from here, then I moved to this point, and then I moved to that point. So all these web pages are actually linked in this way that we call as navigation. So this coverage map is about how an AI engine scanned the application page by page, component by component, and all the test scripts that it could create are actually can be identified from here. So basically that view is not available over here. The green dots that you see highlight the areas of the application against which test scripts were created and they were passed. So there was no problem. And the red dots actually depict that the test scripts that were created, executed. So against those test scripts, there were some defects. For example, the one that you see on the highlighted that we are highlighting. So there was a defect reported somewhere in these red dots. I think so. We have the defect. Fahad, can you click next? Okay, so let's say. So it could be one of the dots that we clicked on. So AI actually not only reported the defect, and it looks like a good defect. It looks like a showstopper or something, and it has captured the image. Oh, now I know that AI is intelligent enough that it made a decision and reported something as a defect, and this whole thing is automatic. And this coverage map is actually in that one particular platform. It was the output of AI driven autonomous testing. I hope I have tried to explain it in the easiest way. Okay, so next slide, please. Uh, Eric, will you take it from here?
Yeah, sure. So just a case study here to kind of hammer it home. This was done recently for one of our new customers, and they're a payment processor with a high degree of visibility, working on behalf of a large global bank. And they were struggling. They were struggling to get their releases out. Their releases were going out with significant leakage, and they weren't getting nearly the quality that they needed. So we got introduced. We moved quickly as we're capable of doing, because not only is Mammoth an accomplished testing organization with lots of foundational capabilities in test, but we're armored with ML and AI and leveraging these enabling technologies in the right way. So we were able to script very quickly. We took on the responsibility of writing the test cases, because these also dovetail into the automation that was aptly created. So within a very short amount of time here, we wrote about 1,000 test cases, 700 automation scripts, and found 177 bugs in their application and 0 defects. This has now been in production for the last 3 months, 0 defects being leaked into production. So very, very powerful case study that speaks volumes of of the power of ML and AI being introduced into continuous test regimen. So I think that's it from our side. Let's see, do we have another slide here? We're into Q&A. So we'd like to open it up for anybody who's got a question. I think on the top of your screen, there's a menu bar for Q&A, and you can go ahead and check on that. Over to you, Fad.
If anyone is having trouble sending in a question, you can feel free to send those separate to me. In the meantime, I have a few that I will go ahead and share so we can start getting those questions answered. And we'll send those over to Eric and Azan to kind of take over there. Anyone else, please feel free to send them in the chat box or in the Q&A box as you feel fit. First question, I'm just going to post it as well. So we have, how does code coverage differ from application coverage?
Okay, Azan, you want to take it or you want me to?
Uh, I Can you please repeat the question?
Yeah.
Actually, I just dropped it.
It's the difference between code coverage and application coverage, right? So I'll give you my thoughts and then I'll turn it over to Azan. So what we're not doing is we're not testing the syntax of code, right? That is, there are tools in the market that are out there that support certain types of what we're doing is we're creating in unified fashion and also very quickly and so being supported by ML and AI in terms of it, we are testing feature and functionality of an application. We are testing the quality of the application, both functional and non-functional. So the difference is that while we're not going through and looking at your lines of code that your dev team is creating, we're looking at, does it meet a feature and functionality that we know is expected of the application, or performance level of that application, or is there something in this application that we didn't know was there and all of a sudden it is there based on the way it's been structured. So we're enlisting the help of AI to basically go across the entire application. That's what we mean by application coverage, and make sure that we don't have any gotchas before we go to release, that we can see everything that's going on inside the code, or at least inside the application. Okay, hope that answers it. Azan, you want to add to that?
I think so. You have kind of covered it, but I'll just give a quick answer on this. Uh, so code is part of the application, and ultimately, when we say that we are measuring the application coverage, we definitely mean that we are also measuring the code, right? So, but we can take them separately also. So, code coverage is where I just try to explain that you're going through all the paths, all the possible paths, connected zones, and the regions of your application source code, and that can be your data also. And then obviously the data is present in the database. Then you have a business logic layer. So testing of APIs, API components is also part of this code coverage thing, because at the end there is a code that is written to interact between all the layers of the or the all the interfaces of of the application. And when we talk about application coverage, then there is the business part of the application associated. So let's say why we have application. We have application to perform a business, run a business, right? And that business is actually enabled through our functionality. So we say we are doing functional testing. So business is also covered through the code, through the front end. Functionalities are also covered through the code, through the front end. So altogether, we are performing kind of like, say, so code coverage is the subset of application coverage. So that's what I believe at the moment, right? Next questions.
All right, so the next question that we have is, can you elaborate how NLP techniques can be used to automatically generate test cases from requirement specifications or user stories? And are there any potential limitations and biases that could arise from this approach?
So yes, so basically, I'll answer this question with respect to your usage of ChatGPT. And this is my most favorite technique in this point of time in this age, because I'll say that what is the input that what is the language that we use to give our input, and that is our natural language. We write in simple English, and whatever we want ChatGPT to, it will do for us. It will do that thing for us, just relying on the input that we have given in our natural language. I mean, like even in our other than English, if we can write something to generate Java code, ChatGPT has the capability of doing that for us. So this particular thing is actually also utilized in our testing space. So NLP actually analyzes and understands the user stories, the requirements, and the test cases that are actually written in natural language, so that automatic generation of relevant test scripts or respective test scripts against those test cases can be done. All right.
Okay. Next question we have, is AI testing going to be another separate role like earlier we have manual or automation testing?
Um,
That's
so
that's a philosophical question.
mm,
You want to take that, Azan, and then I'll follow up.
I think we should take it.
The world of the tester is going to change a little bit. There's no question. It's going to take time, obviously, but the role of let me just say this in general to this notion of AI and what it means to skills disruption, etc. Okay, so there's definitely going to be disruption, no question about it, and that's going to be across the board. But like with all new technologies, that disruption is going to open up the doors for other types of skills that are going to be needed and necessary. So, for example, what we presented today, leveraging ML and AI for continuous test and being able to do it successfully to tackle the problems of the industry, we're able to do that with this type of technique and these types of technologies that are solving a problem today, which is we need to test more, we need to test more broadly, and we need to test faster. And so this solution or this approach is allowing us to do that. Now, certainly there will be overlap, and there will be points at which um, the testing, the things that you do today as testers are going to change. So being able to and where will those change? Where will the changes be? Become. What will it morph into? uh, the what humans are good at in terms of using gray matter is understanding something that's unique and understanding the particular application, the way the application operates, the way the business operates, and the way the business and domain uh, operates, and the processes and the nuances, right? Because no automation can really cover every single thing around it. So tester will definitely be tapped for that and continue to do the things that the tester does in that space, which is more on the front end. So understanding requirements and writing test cases from requirements are still going to be a very critical feature, I think, um, despite what's being done and achieved with ChatGPT, et cetera. Then the other piece is leveraging AI to do it effectively. And so what we've talked about, even though the Mammoth AI team is doing this very effectively today, uh, it takes skill. This didn't happen overnight. We had to, we have the scrapes and bruises to prove that, to use AI in the appropriate way, to leverage it, to make sure that we can have the results that I showcased in the case study, and be able to do that repeatedly for customers. uh, Takes a level of understanding that is way beyond what we do today as testers, whether it be manual or whether it be in the automation space. So what I would say is I would encourage everybody to take it seriously, to do the things that you need to do to understand the concepts of AI and how does AI work foundationally, and then encourage you and your other colleagues, et cetera, and the companies that you work for to adopt this type of technology, not only for the benefit of uh, for the companies you work for, but your own careers. Next
All right.
question.
Thank you for bringing those questions. We have one question, which is, what potential risks are associated with adopting ML and AI for continuous test, and how can we mitigate them?
Okay, so one of the risks obviously is hallucinations, and that's a common issue that occurs when leveraging AI algorithms. Um, and it happens frequently with efforts that are kind of greenfield to develop algorithms. And a lot of times it happens because uh, of the way you create algorithms and you adopt them. So there's a big push now in the industry to be mindful of the data that's being used to train algorithms. These algorithms that we leverage are specifically trained for testing. So right out of the box, that they've been battle tested and benchmarked to make sure that we're not going to experience hallucinations in the use of these algorithms for test. But that is a potential pitfall, particularly if you go down the path of trying to do this and look to create your own algorithms that you can use for test and the types of data that you're going to be using and how to make them work for you. That is where you begin to introduce, if it's not, if the data that you're using is not annotated properly, if it's not annotated exclusively for the types of testing you want to do or the algorithms that you're going to leverage, then you can have hallucinations and be down a path that really you don't want to go down because it is a rabbit hole. So that's the major risk that I see. Azan, you want to add?
Uh, One of the other risks I believe is there. Uh, People would start relying too much on it. I don't think so. We have uh, written or shown any point over here that says that AI will cover everything for your testing, right? Or we may have meant it like that, AI will eliminate the need of other types of testing, and I'm talking about manual testing and the need of people. So problem over here is that when Selenium was introduced in the market or the automation people companies started adopting it. So people just start overusing it. They don't do the feasibility of it. They don't understand the need of anything that is available in the market, and due to which I have a doubt that where there is no need of using ML and AI, there can be some real defects that could be left out, where a human should have seen something that we thought, okay, let's leave it to AI to do it, right? So I think so that is one of the risks I see. So fair usage of everything is actually required for the success of that particular concept.
Yeah, you can definitely kind of when you think about AI in tests, when you think about AI in anything, think about the self-driving cars and self-driving vehicles today and the things that it does um, to benefit your, safe driving and so on and so forth. It provides a lot of great value, but there are things that can potentially cause a problem for you if the AI doesn't read the situation properly at that given circumstance and cannot necessarily apply the rules of engagement. So think about coming to a four-way stop sign, essentially a T in the road, not a T in the road, a crossroad. And you have and each one of the roads has a stop sign there. So who goes first? Should you allow the AI to make that decision? Normally speaking, there is no defined rule of who actually goes first in a scenario like that. So it takes a human to make that decision, to look at the other drivers to see what is their intent and drive, obviously drive defensively and see if somebody enters the intersection to hold off, or at least looks like they're entering the intersection, to hold off and let them pass before you start to advance. Okay. So I hope that helps. Any other questions, Fad? Because I think we're running out of time.
We're running out of time. I think we'll take one more real quickly and then we'll call it a day. It says, how is AI generating test scenarios on its own, and how can we provide confidence for those outcomes?
I wanted to answer this question actually. I was saying it. So it's a very good question. Uh, uh, so the process of generating test scenarios, it's just like, when you go out for your Xerox machine, or in Pakistan it's known as photocopier, right? So AI based platforms, they work similarly like this, right? So when the application under testing passes through these platforms, they kind of take snapshot for everything that is present on all all the interfaces of the application. If there are APIs, they'll note it down. The user interfaces, they'll note it down. If the backend of the interfaces, they will note it down. Everything, right? So now they have this thing, they have this information within them, right? Then the other information, I'll say the large data sets they have uh, are like the technologies of the web applications, mobile applications, and I mean, like, how many types of buttons are there in React? How many types of buttons are there in your JavaScript based application? How many types of operations are there in your uh, I'll say PHP based web applications? So all the types of simulations, actions, a technology provides. So this is the data that the platforms already have. So based on the application that is given to the platform, and the data they already have, so this large, or I'll say tons of data, it provides the information to the platform. Okay, now I know what I see on this user interface. It looks like a button. Oh, okay, it looks like a button. So property X, property Y, property Z, it tells me that this button is a JavaScript button. This button is a React button. This button is it's iOS button, right? So this is how it actually detects the technology types. And further, now AI will look at the application user interface at a whole level. Okay, so what do I see? I see some items in the grid. What do they look like? They look like some general items. So this is how AI is, scanning the application. Okay, I see numbers underneath all uh, uh, these these components, and then I see, oh, add to cart button. Oh, I see a hover button. I see pagination. So these are different trends, patterns, I'll say design patterns that are already embedded into the AI systems, AI-based automation platforms, that gives the intelligence. So I'll not say intelligence, but the word is intelligence to the platforms to make decisions. Okay, I know that this application looks like a e-commerce application. It looks like a web store. It looks like a hospital application. So based on the information that is present in the application on any interface, and the information that is already stored in the database, AI has enough of this data to make decisions, and then to ultimately generate test scripts. But so at the end, if we are totally relying on AI, so this is known as unsupervised, or as say unguided execution. But still, there is a way to train AI. So good platforms, they provide you the options to add validations. They provide you options to train AI. Just like, in ChatGPT, you say, my name is Azan, create my CV. What will be the response? You have just provided a simple line. The response will be, it will create a CV for you, but that CV will be just like a template, right? And maybe ChatGPT tells you, Azan, please give me some information so that I can create a good CV. And the moment I'll give more information, the better information I'll give, the better results, the better response, or my complete CV will be generated. Similarly, uh, a good automation platform that has AI capabilities will allow you to will provide you the options to train the AI, right? To add as many validations and necessary so that AI can also generate good test scripts. All right.
Thank you, Zan, for that
Thank
answer.
you.
So with that, we've come to an end with our webinar on how to adopt machine learning and AI in continuous tests. Thank you everyone for attending. The recording and our e-guide will be available on our website tomorrow where you can review it. Thank you so much for your time, and we'll see you next time.
There
Eric?
are some, yeah, there are some questions, and we'll follow up with those questions. Please just drop your email. No, we already have their email addresses, so
Yes.
we will we'll be able to post that out to you guys. I know there's some additional questions around security and other things, so we'll get to it. Thanks, everybody.
Thank you for your time, guys. Enjoy your day.